Hello and welcome back everyone. In the last session we have talked about the rigid body modes. In this session we are going to discuss the mechanism modes. As the name suggests, very existence of the mechanism mode is due to the mechanism present in the assembly. In this session we will take the example on hinge mechanism. Hinge mechanism can be seen almost everywhere. Most doors in the houses are hinge joint. Vehicle doors get attached to BIW through the hinge mechanism only. For this session, we are going to take the small part of hinge mechanism on hood assembly. On my screen, you can see typical hood and its hinges. For the background, in the green color, I have the body side hinge which will get mounted on the BIW, and in grey color, I have the hood side hinge which will get connected to the inner panel of the hood either through bolted joint or through the welded joint. In between the hood side hinge and body side hinge, we have the hinge joint. In Abaqus, there are multiple ways through which we can model the hinge joint. But for this example, I have created the hinge connector between the two to model the hinge joint. Scope of this video is not to understand the modeling, but to see the modes coming because of the hinge connection. For a time being, imagine, with the hinge connection, hood assembly is allowed to rotate. So essentially, we are releasing the rotation degree of freedom of the hood assembly. So, in addition to the 6 rigid mode, we should get another 0 frequency mode corresponding to the hinge mechanism. The modes which corresponds to some mechanism are typically known as a mechanism mode. Now enough with the theoretical discussion, let's do the exercise practically. Here let us import the orphan mesh file. Simply go for file, let us go for import and let us go for model. Make sure under the file filter Abaqus input file is selected and browse to the location where hood hinges mechanism mode.inp file is placed. Simply click on OK button. Now you can notice over here I have the hood hinges assembly. Now since we are importing the orphan mesh file, the onus is upon us to carefully check the file. For a time being you can observe, even if I try to rotate, it is going out of the plane. Now this is generally happening because our hood assembly is not exactly placed at the 0,0. So whenever we want to rotate it, we need to change the rotation center. To change the rotation center, simply right click over here and let us click on this set as rotation center. Make sure one element is highlighted, and once you do that, now you can rotate it about that particular point. So this is the hood assembly that I have. Now let us go through the file and understand what are the components in this particular model. So let me expand this hood hinges mechanism mode. Under the part, let me expand the part. Under the feature, you can check there are two parts, orphan mesh and there is another O1 rectangular. As of now, even if I am clicking on the model tree, corresponding things are not highlighted in the main window. So let us right click over here and simply go for edit. Okay, currently it is saying the parameters are not readable, but you see, once I go for edit, automatically again if I click on some other part, it is getting highlighted. So let me again click on this rotation center. Let us rotate it and let us zoom in and let us bring to the center. That's it. So this is our orphan mesh, and now if I click on this button, you can see there is a coordinate system which is getting highlighted. This particular coordinate system is important for the hinge connector. Now let us close this one. You can see over here I have the two section assignment. Let us click on this one. So currently it is saying hood side hinges, which are this one, and another one is the body side hinges. Currently the representation is marked based upon the part. If we want to mark the representation based upon the property or section, we can simply go for sections. So these are the two sections, hood side hinge and body side hinge. Let us move over here. Then I have the material. So for the material, currently the name suggests it is steel. But always better practice to check the properties. Make sure you deliberately check the properties, and same do with the thicknesses also. Simply double click on it. Let us click on this section. Let us cancel over here. To check the thicknesses, we can go for the section manager. Simply click over here, go over here and go for edit. So currently one hinge is 2.5 mm and body side hinge, let me quickly check again, 2.5 mm. Let us again close this one. Let us scroll over here. So till now we have understood that we have the three components, One is the body side hinge, another is the door side hinge, and third one is the connector. We have the steel as a material and thickness of both the part is 2.5 mm. Now let us go over here and click on the assembly. Since we are importing the orphan mesh, automatically assembly instance have been created. Even if I go for the assembly, you can see I am able to see the assembly. Now let us again scroll downward, and you can see under the connector section, if I expand, I will get two connector section. One is the MPC section and another one is the connector property. This MPC section are nothing but this section. So you can see these holes are connected through the dotted line. These dotted line are representing the MPCs. MPCs are similar to the kinematic coupling only. So just right click over here and let us go for edit. Once you do that, another window will get open. So let me bring that to the main window. So the MPC type is beam. As of now, let us select OK. As mentioned, MPCs are kind of similar to the kinematic coupling where if you do anything with the one node, automatically same thing will get applied to the reference nodes. Another interesting thing that we have over here is the connector property, which is important for us. Let us zoom in over here. Let us try to rotate it, but first let me change the rotation center. You can notice over here I have the hinge word. So this hinge is nothing but connector which is getting connected to the door side hinge and the body side hinge. Simply right click and go for edit. You can notice here I have the connection type diagram. Simply click on this button. Once you click on the connection type diagram, you will get the diagram representing this connection. So indeed we wanted the hinge connector and go for dismiss. Not only that, you can observe over here. Currently it is saying constraint U1, U2, U3 and rotation about 2 and 3. So along the x-axis the rotation have been freed. And that's the same reason we have the coordinate system over here which is defining the hinge axis as a x-axis. Now let us close this one. So I hope you understood the model setup for this particular problem. Make sure whenever you get the orphan mesh file, you go through that file entirely so that there won't be any surprises for you. Now let us prepare the simple modal analysis deck. Let us go for the step, click on the step manager and let us go for create. Under the frequency, let us put the Lanza solver and under the values, let us put 10. Simply click on OK button. For the output, let us keep the default output only and close it. Now let us go for the job, create the job. So here I will go for hood hinges only. Now let us click on continue and let us submit the job. It will take some time to complete the analysis. Once the analysis get completed, let us go for the results. Now as per our understanding, since there are no boundary condition, first 6 modes are going to be 0, which will be known as an rigid body modes. But since there is one another hinge connector connecting the hood side hinges and body side hinges, there is going to be one additional 0 mode. So let us quickly check that. Let us go for result, step and frame. Under the mode, you can notice first to 6 modes are 0 only, but in addition to that there is a 7th mode which is also equal to 0. Mode animation for this mode is going to be interesting one. So let me apply this mode and let us play the animation. You can notice in the animation it looks like body side hinge is rotating. Now here, in order to get the better understanding, one thing that we can do is to fix the body side hinge itself. One might ask a question, why the body side hinges? Because typically there are a lot of load cases which will get performed on the hood alone. Since this particular body side hinge will get mounted on the BIW which is much stiffer, it makes sense to constrain these two locations. Now let us quickly go to the loads. From here let us go for constraint, just to understand the rotation. So here I will go for the symmetry, go for continue. As I have mentioned, these two nodes act like a reference node or the control point. So simply let us go for the mesh. Here I will go for individual. Let us select this one, press and hold shift button and select another one. Now let us go for incasted and go for OK. Once the boundary condition have been applied, let us go for the job. And here let us create another job. So here I will go for job 2. Let us go for continue and let us submit the job. So basically, since we are applying the boundary condition, there won't be any rigid body modes. But since there is one additional degree of freedom for the assembly itself, there will be one mechanism mode. Let us go for the results now. And let us go for the results and step and frame. You can see the first mode is the 0 mode. Let us apply it and go for OK. Let us go for the contours. And now let us play the animation. With the animation, we can clearly see hood side hinge is rotating about the body side hinge. So I hope you got the concept of mechanism mode. So let us meet in the next session. Till then, take care. Goodbye.